Hello everybody, welcome into another lesson. So today we start the unit on three-dimensional analytic geometry. And today's lesson should be fairly easy. We're just going to introduce the three-dimensional coordinate system. Now, three-dimensional analytic geometry is something that will come up again if you go on to take Calculus 3, which is often called multivariable calculus. It'll also come up in a course called linear algebra, which comes after that. So, granted we're not going to use much of this in Calculus 1 and 2, but in Calc 3 and higher we will use a lot of 3D geometry. So here on this magnetic board I have a 3D plane. You have the x-axis, which runs right here, and this is in the positive direction. It could extend that way to go in the negative direction. Down here you have the y-axis, which goes in the positive direction, and it could extend to the left to go in the negative direction. And then going top to bottom here, where the x and y-axis meet, you have the z-axis. Well, the z-axis, of course, could extend downward through the paper into the board if we kept going. Well, how can you help yourself understand the XYZ plane? So if you're in a room anywhere, face a corner of your wall. Just face a corner. So if you look at your baseboards on your floor, if you look going one way on the floor, you could picture the x-axis. If you look at the corner and make a turn, you could picture the other way being the right axis. And then if you look up where the two walls come together, picture that being your z-axis. That's probably the best way to help you understand the XYZ coordinate system. And in the two-dimensional system we had XY ordered pairs. Well, in the three-dimensional system we have XYZ ordered triples, where the x coordinate comes first, then the y coordinate, then the z coordinate. So it's not terribly much different than the two-dimensional system. The only thing is we've added height to it in the z-axis. So we're going to start real easy. We're just going to plot some points. We're going to plot a couple points here. I won't spend long on this because it's really pretty basic. Let's say we plot 3, 0, 0. So they ask you to plot the order triple 3, 0, 0. Well, your x-coordinate comes first. So you notice your y and z coordinates are 0, so you're going to be on the x-axis. So we start at 0, here's 1, 2, 3. So right about there would be your order triple 3, 0, 0, is right about there. Again, it's just a matter of understanding your coordinates. X first, y second, and then z is last. Alright, now let's say we wanted to plot 4, 4, 0. Let's plot 4, 4, 0. So this time you have an x and y coordinate with actual numbers. Your z coordinate is 0. So you're just going to be in the xy plane. So what does that look like in 3 dimensions? So if I go 4 here on the x plane, 1, 2, 3, 4, I'm about right here. So this will be 4, 4, 0. My height is 0. I haven't left the ground. I've just gone into the xy plane at 4, 4, 0. Alright, let's do one where we have numbers for all three. And what a good place to start. We have 1, 2, 3. So I'm being asked to plot the order triple 1, 2, 3. So first deal with my x-coordinate of 1, right about there, my y-coordinate of 2, right about there, And then I'm going to go up about 3. If I take my finger, go up about 3 units, I'm right there. You can pretty much just draw a dotted line to help you get to that height of 3 if you want. If you take your XY coordinates and draw a dotted line, then you'll be about at your point right here. And drawing in 3D is not perfect because drawing in 3D is actually incredibly hard. But this would be about where your ordered triple 1, 2, 3 is. Because it's over 1 on the x-axis, over 2 on the y-axis, and then it has a height of 3 on the z-axis. So it might help you to draw, when you get your xy coordinates, to draw your z, from that point, draw a dotted line up about 3 units to get yourself your height, to illustrate you're in the third dimension. So this is going to be my ordered triple 1, 2, 3. Alright, let's mix it up a bit. What if I did negative 1, 2, 1? Alright, so all of a sudden I have a negative x coordinate. Well, that's going to be over this way. Negative 1 in my x is about here, y is about 2, right here. So if I go to negative 1, 2 and go up about 1 unit, we'll say right there, that would put me at about negative 1, 2, 1. So my advice, again, fill out your x and y coordinates. And then when you reach your xy coordinates, draw a dotted line however much height you need in the z, and then you'll reach your z coordinate, and then you'll have plotted your ordered triple, negative 1, 2, 1. Let's plot one more. Good one. So we're going to plot 5, negative 2, negative 2. So we're going to plot the ordered triple 5, negative 2, negative 2. So that means first what we need to do is go 5 in our positive x direction. So about 1, 2, 3, 4, 5. Now notice my x coordinate, my y coordinate's negative 2, so I'm going to the left. That'll put me right about there. And then I actually need to go down 2 units for my z coordinate because the z is negative. So right about there, I'm going to draw a dotted line and go right about here for about 2 units. That would put me at 5, negative 2, negative 2. Right about there in my z system. So I know it gets a little discombobulated trying to plot in 3D, but just visualizing the corner of the wall might help you draw this. As you can tell, I'm not an artist, but if you can visualize the corner of a wall where you look at the baseboards again where your floor meets the wall, let's say you're facing the corner, going left would be your x-axis, going right would be your y-axis, then if you look up where that seam is, where one wall meets the other, that's your z-axis. That's probably the best way to help you visualize this. Alright, so those are plotting points. Now we're going to talk about the 3D distance formula. So yes, we can find the distance between 2 points in space. So if we remember, the distance formula in 2 dimensions was the square root of our x2 coordinate minus our x1 coordinate squared plus our y2 coordinate minus our y1 coordinate squared. That's in 2 dimensions, but we have a 3rd dimension. All that's going to do is this is going to be plus the z2 coordinate minus the z1 coordinate squared. It's going to be the square root of all that for the 3D distance formula. So all this is you take the 2-dimensional distance formula and you add your z coordinates, the z2 minus z1 quantity squared under the square root, and you have your 3D distance formula. So we'll find the distance between a couple points. So we're going to be given the points -1. Let's see, what do they have us? -1, 4, -2, and then we're going to have 6, 0, -9. So we're going to find the distance between points, the ordered triples, -1, 4, -2, and 6, 0, -9. Well, to help us visualize this, why don't we plot these points? So -1 on the x would be about right there. 4 on the y would be about right here. Okay, from there let's draw our dots down 2 units, and that would put us right there at -1, 4, -2. Now let's also draw 6, 0, -9. So if we go 6 in the positive direction on the x-axis, so 1, 2, 3, 4, 5, 6. Now we don't go anywhere on the y because y is 0, but from about here we're going to go down 9 units on z. So we'll draw our dotted line. That's going to, we'll say that'll put us about right there at 6, 0, -9 for that ordered triple. And if you like, you can draw a line to connect these 2 points, because that distance is also the length of that line in space, that line segment. So now we can use this distance formula to find our distance. So in this case, the distance would equal the square root of our x2, which is 6, minus our x1 minus -1 turns into +1, quantity squared, plus our y2 of 0 minus our y1 of 4, quantity squared, plus then our z2 of -9 minus our z1 of -2. That would turn into -9 plus 2, quantity squared. So let's simplify this. You'll get the square root of 7 squared plus -4 squared plus -7 squared, which would turn into the square root of 49 plus 16 plus 49. So that would end up giving you the square root of 114. Which really I don't believe we can do anything with. Maybe I'm wrong. Let's see if this factors at all. I'm not so sure it does. Nope, it doesn't factor. So the distance between these 2 points is the square root of 114 units. That's exactly what you would get using the 3D distance formula. You get a length of the square root of 114 units, which is more than 10 units. Let's do another distance. Alright, so let's do another couple order triples. We'll find the distance. So we're going to have one order triple being 1, 1, -7. Then the other order triple is going to be -2, -3, -7. So we need to find the distance between 1, 1, -7 and -2, -3, -7. First, what I like to do if you're just finding the distance, you don't have to plot these unless your professor or teacher tells you to. But I'm going to draw these to help us visualize it. So 1, 1, negative 7. So I'm going 1 on the positive x, 1 on the y. I found my 1, 1. From there, let's draw some dotted lines down about 7 units. This would put me at the ordered triple 1, 1, negative 7. Now, the next coordinate I have is negative 2, negative 3, negative 7. So I'm going to go 2 in the x direction, negative, right here. Negative 3 in the y direction, right about there. Now that I've found my xy, I'm going to go down about 7 units, and that would put me about right there at negative 2, negative 3, negative 7. So there's that ordered triple. I can always draw a line to connect them to show you that that distance is what I'm trying to find, the length of that line segment connecting these two ordered triples. Alright, so let's find the distance. So the distance then would be the square root of all this. So our x2 is negative 2 minus our x1 of 1, quantity squared, plus our y2 of negative 3 minus our y1 of 1, quantity squared, plus our z2 of negative 7 minus our z1 of negative 7. Well, negative 7 minus negative 7 turns into negative 7 plus 7, quantity squared. So let's simplify this. Negative 2 minus 1, that would turn into negative 3 squared, plus negative 3 minus 1, that's going to turn into negative 4 squared. Now negative 7 plus 7, that would turn into 0 squared. So this would just turn into the square root of 9 plus 16, because 0 squared is 0. Well, the square root of 9 plus 16 is the square root of 25, which we know to be exactly 5. So the distance between these two ordered triples would be 5 units. So this would have a length of 5. Alright, so I think the distance formula is relatively pretty easy. Now, of course, we also have a 3D midpoint formula. You can actually find the midpoint of a segment joining two ordered triples in space. So let's do that here. Let me put up the 3D midpoint formula. And as you're going to see, it's very similar to the 2D one, only we're adding the z dimension. So if you want to find the midpoint of two ordered triples, if you remember in the 2 dimensions, the midpoint, of course, you'll have x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 over 2. And that would give you, of course, in the xy plane, that would give you the midpoint of two ordered pairs. Everyone should be familiar by now with the 2-dimensional midpoint formula, but the third dimension is very similar. All you're going to do is comma z sub 1 plus z sub 2 over 2. That's all you do for the third dimension. You just add that z aspect. So it's actually very easy to find the midpoint of two ordered triples. So let's do that here. So let's say we are given the points 3, negative 6, 10. And then we're also given negative 3, 4, 4. So we have two ordered triples. We have 3, negative 6, 10, and negative 3, 4, 4. Well, we can easily find the midpoint, but let me plot these real quick. So 3 on the x would be about right there. negative 6 on the y, so I have to go this way. That put me about right here. Once I found my xy, I'll just draw my dots and go up about 10 units here. And then I'll plot my point in space. This would be 3, negative 6, 10. And then we need to also plot negative 3, 4, 4. So negative 3 on the x would be going this way, right about here. 4 on the y is about right there. Once I found my xy coordinates, I'll draw some dots, go up about 4 units here in space. This would put me at negative 3, 4, 4 for my second ordered pair. Our goal here is to find the midpoint of this line segment that joins these two ordered triples. So let's do that. So the midpoint, of course, I'll just say midpoint is equal to, well, x sub 1 is 3 plus negative 3, so that'd be 3 minus 3 over 2. Y sub 1 is negative 6 plus y sub 2, that's 4 divided by 2. And then z sub 1 is 10 plus z sub 2 is 4 all over 2. Well, this would simplify into 0 over 2, negative 2 over 2, and then 14 over 2. So the coordinates of the midpoint itself should be 0, negative 1, 7. So the midpoint of these two ordered triples would be at 0, negative 1, and then 7, which would be about right there, roughly. So there's roughly 0, negative 1, 7. And you're never going to get this real exact unless you use computer software to generate your 3D sketch. But there's roughly your midpoint for these two ordered triples. Let's do one more midpoint, and then maybe we'll actually play around with a couple triangles. I do like 3D geometry a lot, however, let me say, because I think it's cool to be able to bring this to life in 3D as much as we can. Alright, let's erase all that extra stuff there that we don't need to see, because that's just going to lead to some confusion, like I plotted other points, which I haven't, so let's just clean that up a little bit. Maybe I'm OCD a bit, I don't know. But anyway, I digress. Let's find another set of midpoint here. Let's give you two more ordered triples and find the midpoint. Alright, so we have negative 1, 5, negative 3, and then we also have 3, 7, and negative 1. So we have the two ordered triples, negative 1, 5, negative 3, and then 3, 7, negative 1. First, let me plot these to show you what this is going to look like. So negative 1 in the x direction, that's about right there. Over 5 in the y direction, that's about right there. And then go down 3, draw a little dot, go down 3 units in z, that's about right there. So here is going to be your negative, here is your negative 1, 5, negative 3 coordinate. Now, what about your other one? How about 3, 7, negative 1? So you're going to be over 3 in the x coordinate right about here, go over 7 in the y, we'll put that right about here, and then just go down 1 point for the z. That would put you right there at about 3, 7, negative 1. So what we want to find is the midpoint of these two ordered triples, or the line segment that joins them. That's another way to think of it. So let's go ahead and find the midpoint of these two ordered triples. So midpoint, that's going to equal, take your x1 of -1 plus your x2 of 3, divide that by 2, take your y1 of 5 plus your y2 of 7, divide that by 2, then take your z1 of -3 plus your z2 of -1, divide that by 2. This will simplify into 2 over 2, 12 over 2, and then -4 over 2. So your midpoint itself should be at 1, 6, -2. So the midpoint of these two ordered triples should be at about 1, 6, -2, which is going to be somewhere about there. There's your midpoint. I'll call that M. So yes, finding the midpoint is really pretty easy. Now let's deal with some triangles in space. I think it's kind of cool to start to be able to draw shapes in space, personally. So we're going to be given the vertices of some triangles, and we need to determine whether or not they're scalene, isosceles, or right triangles. So let's go ahead here. We'll say point P has the coordinate 1, -3, -2. Point Q has the coordinate 5, -1, 2, and then point R will have the coordinates -1, 1, 2. Alright, so we have a triangle with points P, Q, and R. These are the three vertices of the triangle. Let's plot point P. So 1 on the X, 3 to the left on the Y, and then down 2 for Z would be right about there. So here's your point P. Now let's find point Q. It's 5 on the X, so right about there. To the left on your Y, and then up 2 would be right about there for point Q. And then point R, we go negative on the X, so right about here, +1 on the Y, and then up 2 on the Z is going to put me about right here for point R. So now I'll just connect my vertices, and we will have a triangle in space. What do you know? We have a triangle in space. So how are we going to determine whether it's isosceles, scalene, or right? Well, we're going to have to find the length of each side, which means the distance formula. So a good place to start, I'm going to say, is PQ. Let's start with side PQ. PQ, to find the distance of that, you'll get the square root of, so take your x2 coordinate of 5 minus your x1 coordinate of 1, square that, plus your y2 coordinate, which is -1, minus your y1 coordinate, which is -3. Well, this would turn into -1 plus 3 squared, plus take your z2 coordinate of 2, minus your z1 coordinate of -2. This would turn into 2 plus 2 quantity squared. Well, we can simplify this. This is going to turn into the square root of 4 squared plus 2 squared plus 4 squared. Well, this turns into the square root of 16 plus 4 plus 16. Well, that actually gives you the square root of 36, which we know to be 6. So side PQ itself would have a length of 6. Now, what about the other two sides? Well, we got to apply the distance formula once again. So let's do side QR. QR, let's apply the distance formula. So x2 is -1 minus our x1 of 5, that quantity squared, plus the y2, which is 1, minus the y1, which is -1. This would turn into 1 plus 1 squared, plus the z2, which is going to be 2, minus z1, which is also 2, so 2 minus 2 squared. Well, this would simplify into -6 squared plus 2 squared plus 0 squared, which would end up giving me the square root of 36 plus 4 plus 0, which is just the square root of 40, which would simplify into 2 times the square root of 10. So QR has a length of 2 times the square root of 10. Now, what about PR? That's definitely the third side, right? We need to find the length of PR. So let's do that. We'll find the length of PR. So let's take the distance formula. x2 is -1 minus your x1 of 1, so -1 minus 1 squared, plus your y2 of 1 minus your y1 of -3. This would turn into 1 plus 3 squared, plus then you'll take your z2 of 2 minus your z1 of -2, so this would be 2 plus 2 quantity squared. So this is going to turn into the square root of -2 squared plus 4 squared plus 4 squared. Well, that's going to simplify into the square root of 4 plus 16 plus 16. That's the square root of 36, which we know to be 6. So PR also has a length of 6. Well, if PR is equal to PQ, this is an isosceles triangle, right? So triangle PQR is an isosceles triangle because two of the sides are equal to each other. So we're going for equilateral, scalene, or isosceles. We want to determine if they're equilateral, scalene, or isosceles. Let's do one more with a triangle, then we'll be done with the lesson. Alright, let's change the coordinates here for the triangle we're about to do. So P has coordinate of 1, -2, -1. Q has a coordinate of 3, 0, 0. And then R has a coordinate of 3, -6, 3. So now we have triangles. We have a triangle PQR with these given vertices. Let's plot point P. So 1, -2, -1, so we'll go 1 in the positive x direction, to the left to go 2 in the negative y direction, then we'll go down 1 in the z direction. So here's point P. Now what about point Q? That's just at 3, 0, 0, so we're only going to go on the x direction. That would be about right there. Here's point Q. Point R is going to be at 3, negative 6, 3. So here's about 3 in the x direction. And then we're going to go to the left 6 units in the y direction, right about there, then go up 3 in the y direction. That would put us about right there. So here's point R. So let's connect these vertices. Alright, so there is our triangle in space with points P, Q, R, with the vertices P, Q, and R. To determine whether it's scalene, isosceles, or equilateral, we need to find the length of each side. So let's find PQ first. PQ, well, that's going to be the distance formula between points P and Q. So x2 is 3 minus your x1 of 1 quantity squared, plus your y2 of 0 minus your y1 of negative 2, that would turn into 0 plus 2 quantity squared, plus your z sub 2, which is 0, minus your z sub 1, which is negative 1, well, that would turn into 0 plus 1 quantity squared, which would simplify into 2 squared plus 2 squared plus 1 squared. Well, this is going to simplify further into the square root of 4 plus 1, which would become the square root of 9, so that means PQ has a length of 3. So PQ has a length of 3, now we need to find the other two sides. Let's find PR. Yeah, we'll go for PR. It doesn't matter which order we go in. So PR, well, that is going to be then the square root of, we're going to take the distance, so x2 is 3 minus our x1 of 1 quantity squared, plus our y2 of negative 6 minus our y1 of negative 2, so that would be negative 6 plus 2 quantity squared, plus the z sub 2, which is 3, minus your z sub 1, which is negative 1. This would turn into 3 plus 1 quantity squared. Well, that's going to simplify into 2 squared plus negative 4 squared plus 4 squared, which would end up turning into the square root of 4 plus 16 plus 16, which is going to be the square root of 36, which would just be 6. So side PR has a length of 6. Now, the only other side to find is QR. So let's go for QR. So let's find the distance between points Q and R. So our x2 is 3 minus our x1 of 3, so 3 minus 3 squared, plus the y2 of negative 6 minus the y1 of 0 quantity squared, plus our z2 of 3 minus our z1 of 0 quantity squared. Well, this is going to simplify into 0 square root of 0 squared plus negative 6 squared plus 3 squared. So that's going to simplify further into, well, 0 squared is 0, so this would be the square root of 36 plus 9, which is the square root of 45, which breaks into 3 times the square root of 5. So QR has a length of 3 times the square root of 5. And now, given that we have the length of all 3 sides, none of them are equal. So this would actually be a scalene triangle because none of the sides are equal to each other. Alright, so that's it for this lesson. Next lesson we'll talk about spheres. We're going to graph some spheres in 3D, of course, because they are 3D. We'll find the equation of spheres, and we'll use the equation to find the center and the radius. And then we're also going to talk about something called traces involving spheres. That's the idea of taking a sphere and translating it to 2D. What would that equation look like in 2D? And what would you get if you traced it? So, I hope everybody has a great day. Take care.